Welcome to lesson 6.2 on transforming random variables. McHenry County Community College in Crystal Lake considers a student to be full-time if he or she is taking between 12 and 18 credits. The number of credits, X, that a randomly selected student at MCC is taking and the fall semester has the following distribution. So here's how many credits they're taking and the probability of taking those credits. Draw a probability histogram. So our probabilities range from pretty small to about 0.3. So I'm going to use that as my y-axis and label it probability. My x-axis is number of credits, and this is the full-time students' credit hours. Okay, so we see most students taking 12 credit hours or 15 credit hours, and then decreasing in 13, 14, and 16, 17. That's probably because most classes are 3 credit hour classes, so it comes in multiples of 3, like 12, 15, or 18. Okay, calculate and interpret the mean of x. So mu x is equal to each observation times its probability. So 12 times 0.25, 13 times 0.1, and so on. So we write that all out, and then we get 14.65 credit hours as the average number of credit hours weighted by the likelihood of each of the credit hours. Okay, always actually use one variable stats to get this number. Don't actually rely on yourself being able to type in all like 20 of these buttons correctly. And then to interpret. If we randomly select many students, then a typical MCC full-time student will take about 14.65 credit hours. Calculate and interpret the standard deviation of x. Sigma x is equal to the square root of each observation minus the mean squared times the probability of that observation occurring. So 12 has a probability of 0.25, and the mean is 14.65. So 12 minus 14.65 squared times 0.25, and then the 13, and then ... And they're all summed together, and that equals 2.056 hours. Remember, this is a standard deviation. The number of credit hours taken by a full-time MCC student typically differs from the mean by about 14.65 hours by about 2.056 hours. So making the histogram in your calculator, you're going to follow these steps. And then to yourself personally adjust your bin widths, you can follow these steps. Not totally necessary because, your histogram by hand should be just easy enough because you're just reading the observation and the probability and writing them all out. Okay, at MCC, the tuition for full-time students is $107 per credit hour if the student lives in McHenry County. So if T equals tuition charge for a randomly selected full-time student, then T equals 107x. Here's the probability distribution for T. So what we're doing is we're taking 12 credit hours times $107, and we're getting that this person will it will cost this person $84. It'll cost a 13 credit hour person $1,391. So we can take all of our credit hours from the table before and just change that first line by multiplying each of them by the $107 per credit hour, and we can get the tuition charge. And the probability all stays the same because this is the probability of someone taking 12 credit hours, so that's now the probability of someone being charged the amount for 12 credit hours. This is the probability of someone taking 13 credit hours. This is the amount charged for 13 credit hours. So instead of credit hours, we've just changed it to amount charged for those credit hours. Calculate the mean and standard deviation of T. So this time I'm not asked to interpret, I'm just asked to calculate. So I'm going to take each observation times its probability. And over here I'm going to take each observation minus the mean of 1,567.55 squared times the probability. Okay, and then add them all together. So I get a mean of 1,567.55. That means that on average, the average full-time student in MCC in this fall was charged $1,567.55 for their education, and that varies by about $220 on average. So here is my histogram of T, not of the mean or standard deviation. The mean is somewhere around here-ish, 15.67, okay? And there we see 12, 13, 14, 15, 16, 17, 18, $19,000. And sorry about that last one there. For tuition, what is the effect? Oh yeah, that's right. That last one belongs there. I just had the wrong height. Okay, What is the effect of multiplying or dividing a random variable by a constant? So what happened to the shape? What happened to the center? What happened to the spread? The shape of the distribution remained the same. Okay, we still had this three-tier decrescendo, if you will, and then this one here. Three-tier, and then that one there. Okay, shape remains the same. Center, our center is now 1567. It was 14.65. If we took 14.65 times the 107 charge, we get 1567.55. So why would we ever do all this by hand if we can just simply take a mean and multiply it by the constant? That's especially important because if you had a normal distribution and you could just find your new mean of a transformed data, then that would be really easy to find, and then you can find probabilities under a normal curve really easy because you do need a mean and a standard deviation to find those probabilities under a normal curve. And probabilities of transformed data, 2.056 times 107 would be great to be able to calculate easily. Okay, so that's great. Now, so center is multiplied or divided by the constant. Spread is also multiplied or divided by the constant. Now, the reason that there's a little bit of a rounding error is because my calculator might have taken and rounded some of these values here as it went, because it's subtracting, squaring, multiplying, and square rooting again. Okay, so there might be a little bit of a round off error type of thing. Okay, in addition to tuition charges, each full-time student at MCC is assessed a student fee of $23 per semester. So what we're going to do is we're going to add $23 more to each of their fees. If C is the overall cost for a randomly selected student, then take 23 plus T to get your C. Okay, so then show the histogram for C. All that we're going to do is we're going to move each of these up by $23. So 1284 is now 1307. 1391 is now 1414. But as you can imagine, all my probabilities stayed the same, so it's going to go down in order from 0.25 to 0.10 to 0.05 still, and it's still going to do the same thing as we had before. So let's discuss. First, sorry, I'm jumping ahead of myself. Calculate the mean and standard deviation. You should show your work, but this is just becoming repetitive for a notes packet, so I'm just going to drop them in here. My mean is 1590.55, but my standard deviation remained the same. Okay. What is the effect of adding or subtracting a constant by a variable? The shape remains the same. The center is added or subtracted by that constant. The spread remains the same. Okay, so linear transformations. For any random variable x, a linear transformation is in the form y, our new variable, equals a multiplier or a divider and an adder or a subtractor, where a is addition or subtraction constant and b is a multiplication or division constant. How are shape, center, and spread of x changed? In other words, how does a linear transformation affect shape, center, and spread of a random variable, including specifically addressing mean and standard deviation for center and for spread? So multiplication or division is the shape remains the same, the center is multiplied or divided, and the spread is multiplied or divided. The addition and subtraction variable, though, does these things. The shape remains the same, the center is added or subtracted, but the spread remains the same. Okay, so for test scores. In a large introductory statistics class, the distribution of x equals the raw score in a test was approximately normally distributed, extremely important information, with a mean of 17.2 and a standard deviation of 3.8. The professor decides to scale the scores by multiplying the raw scores by 4 and adding 10. Define the new variable y to be the scaled score of a randomly selected student from the class. Find the mean and standard deviation of y. So we're going to do these two things. So it's best maybe to start with a little formula for yourself. The new random variable y is going to be all the old scores multiplied by 4, then to add 10. And this is written in the form y equals a plus bx, the way that AP Stats class likes it. Okay, so let's talk about the mean of y. That means I'm going to transform now. Instead of transforming all the data, which I don't even have, I'm just going to transform the mean itself, the old mean of x. So I'm going to take the 17.24, and centers get multiplied and divided, and they get added and subtracted. So I'm going to do both moves. I'm going to multiply by the 4, and I'm going to add the 10 to the center. So multiply by 4, add the 10. So 17.2 times 4 plus 10 gets me 78.8. The standard deviation, though, is a measure of spread. It only gets multiplied or divided. It does not get affected by addition or subtraction. So I need to make sure that when I put spread in the input spot, in the x, that I only do the multiplication, that I skip the addition step. So 4 times Sx, or sigma x, is 4 times 3.8, which is 15.2, because sigma is not affected by addition or subtraction. What is the probability that a randomly selected student has a scaled test score greater than 90? So I'm curious about the 90 line and on up. So what I have to do is I have to start with a normal curve, and I have to put my 78.8 in the middle, and I have to count by 15.2s. So 78.8 goes there, 15.2 more is 94, then 109.2, and 124.4. On the other side, 63.6, 48.4, 33.2. Okay, so what I'm going to do then is take each observation minus the mean over the standard deviation. So the probability that y is greater than 90 is the probability that z is greater than the z-score for 90. So 90 minus 78.8 divided by 15.2. So that's a probability that z is greater than 0.737. So that is equal to 0.235. A large auto dealership keeps track of the sales made during each hour of the day. Let x equal the number of cars sold during the first hours of business on a randomly selected Friday. The random variable of x has a mean of 1.1 cars sold in the first hour and a standard deviation of 0.943. Suppose the dealership's manager receives a $500 bonus from the company for each car sold. Let y equal the bonus received from the car sales during the first hour on a randomly selected Friday. Find the mean and standard deviation of y. The mean of y is 500 times the x. I'm sorry, y, the variable y is 500 times x. It's just a linear transformation rule. So the mean of y is equal to 500 times the mean of x, and the standard deviation is also 500 times sigma x. So that's 500 times 1.1 for the mean, 550, and 500 times 0.943, which is $471. To encourage customers to buy cars on Friday mornings, the manager spends $75 to provide coffee and donuts. The manager's net profit, T, on a randomly selected Friday is the bonus earned minus the $75. Find the mean and standard deviation of T. T equals the bonus earned minus $75. So mean of T is mean of y minus 75, which is $550 minus 75, and the standard deviation does not get affected by the subtraction. Sums and differences of means. Combining random variables. For any random variables x and y, the sums of the means is the mean of the one plus the mean of the other. That means the expected value of x plus y is the expected value of x plus the expected value of y. And the difference of the means is mu x minus mu y. Can also combine more than two random variables. So if t is x1 plus x2 plus x3, then mu t is mu x1 plus mu x2 plus mu x3. Note that the shape of the sum or difference will vary depending on the shape of the components. Okay, calculate the theoretical mean of male minus female height. So mean of male minus female height is mu male minus mu female. Now, in this speed dating exercise that we're going to skip over here, we said that a male has a height of 69 inches and a female has a height of 64 inches. Okay. So then if we're going to find that theoretical difference, we're going to say 69 minus 64 is 5-inch difference on average. Sums and differences of variances and standard deviations. You cannot just add and subtract the standard deviations. For any random variables x and y, the sum of the variances is sigma x plus y squared is sigma x squared plus sigma y squared. So in order to find the variance of the sum of the variance of the sum of random variables, we have to take the variances and add them up. We cannot take standard deviations and add them up. So make sure that you square the standard deviations, add them, and then you can square root again to make it back to a standard deviation. Same thing for the differences. So the sum of standard deviations, sigma x plus y equals sigma x squared plus sigma y squared, square rooted. Same thing for a difference, but when you find a difference, standard deviation of the difference of two random variables, it's still going to be an increased amount of standard deviation. So we have to have a plus sign still in the difference of standard deviations. So sigma x plus y is the same as sigma x minus y in terms of the sum of two random variables, or the difference of two random variables formulas goes. In general, the variance of the sum of several independent random variables is the sum of their variances. This is similar to the relationship of Pythagorean theorem, where a squared plus b squared equals c squared kind of idea. Okay, calculate the theoretical standard deviation for male minus female distribution in the speed dating example. What is the theoretical probability that a randomly selected male speed dater is taller than the randomly selected female speed dater he is paired with? So sigma m minus f is equal to sigma m squared plus sigma f squared square rooted. So we're going to say 4 squared plus 2.5 squared, using those numbers from the page before. A male's height has standard deviation of 4, and a female's height has standard deviation of 2.5. So what is the standard deviation of their differences, of their difference of heights? We're going to add the variances and then square root, and we get 4.72 inches is the standard deviation of the distribution of their differences in height. So their differences in height had a mean of 5 inches for their average difference in height, meaning on average males are 5 inches taller than females, with a standard deviation of 4.72. So we count up by 4.72s and count down by 4.72s, and it's fine that we have negatives down here. This would mean that the female is taller by 4.44 or 9.16 inches. Okay, so what's the probability that the male is larger than the female? So that therefore, what's the probability that the male minus the female is greater than 0? The difference is greater than 0. So all the times that the difference is greater than 0, the male is taller. So we're going to use the 5 for the mean and the 4.72 for the standard deviation. So what's the probability that z is greater than the difference, the z-score for the 0 observation? So 0 minus the mean 5 over 4.72, the standard deviation, is the probability that z is greater than negative 1.059, and that's 0.855. So there's an 85.5% chance that two randomly paired people will result with the male being taller. The rule of independence. If knowing whether any event involving x alone has occurred tells us nothing about the occurrence of any event involving y alone and vice versa, then x and y are independent random variables. Probability models are often assumed to be independent when the random variable's outcomes appear unrelated. So the two events, male's height and female's height, seem unrelated and independent, and that's important in order to calculate the standard deviation. Okay, if variables are not independent, you can use the law of cosines, but AP only requires independent case. Okay, so we're not going to use any other rules to get around independence. We do, therefore, require that the two variables be independent. Okay, so if t equals x plus y, this has no context, okay? If t equals x plus y, you can think of t like total. Then, and mu x and mu y are these values, and sigma x and sigma y are these values. Find the mean and standard deviation of t. Remember that t is the sum. So what we're going to do is we're going to say mu t equals mu x plus mu y equals adding the means. Sigma t, with always a plus sign, is sigma x squared plus sigma y squared, adding the variances, and then square rooting. So 0.2 squared plus 1.3 squared, and we get 1.315. Siblings Pete and Aaron give half-day trips as tour guides in their cities, San Francisco and Charleston, respectively. Below are the probability distributions for each tour business. Let x equal the number of passengers on a randomly selected half-day trip with Pete, and let y equal the number of passengers on a randomly selected half-day trip with Aaron. So Pete and Aaron do tours of their cities, and they have these many passengers, 2, 3, 4, 5, or 6, and she can only have 2, 3, 4, or 5. So here is their mean and standard deviations. If t is the total passengers that Pete and Aaron have on their tours on a randomly selected day, what is the average of t? It's important to first consider that these are independent random variables because they're in different parts of the country. And so we assume that there's different weathers, therefore, and we assume that if one can tour, that the other can or can't tour based on their own weather. So, so we consider them independent random variables. So then we can add their means, and we take their mean, and we get 6.85 passengers. This is the total amount that that whole family business can bring in, the total number of passengers that they can tour. And the standard deviation of the number of passengers is to add the variances. So we square them both, add them up, then square root. We get 1.44 passengers. Suppose that a certain variety of apples have weights that are approximately normally distributed. Okay. With a mean of 9 ounces and a standard deviation of 1.5 ounces. If bags of apples are filled randomly selecting 12 apples, what is the probability that the 12 apples is less than 100 ounces? So I want to use some variables, so I want to go ahead and start defining them because this is the first time a prompt has not defined them. So let x equal the weight of a randomly selected apple, so x1 is the first apple, x2 is the second apple. Let t equal the total weight of the 12 apples. So then t is the total weight. It's each of these independent apples being added up. As we know, one apple won't affect the next because the apples are just their own sizes. Okay, we want to find the probability that t is less than 100. We need mu t and sigma t to use normal approximations. Because t is the sum of 12 independent normal random variables, then t follows a normal distribution with mu t, and I define it as being all the weight of 12 apples, and sigma t being the standard deviation is 12 of these 1.5 squareds, square rooted, and so we get 5.2. Now what's the probability that that total weight is less than 100? That's the z-score for 100, so 108 and 5.2 are necessary, and then we get a z of negative 1.54, which is 0.062, and there is my 108, counting by 5.2s, and my goal area shaded. Let B equal the amount spent on books in the fall semester for a randomly selected full-time student at MCC. Suppose that mu B is 153 and sigma B is 32. Let C equal the overall cost for tuition and fees for a randomly selected student at MCC, where mu C is this and sigma C is this. Find the mean and standard deviation of the total tuition and fees and books, so cost plus books, for a randomly selected full-time student at MCC. So sigma C plus B cannot be determined because the cost for tuition and fees and cost for books are not independent random variables. It doesn't make sense to add up any two students' cost and books. It makes sense to add up student one's overall tuition and fees with student one's books. And if student one only took 12 credit hours, then they'll have fewer book fees, where student two will have larger book fees, maybe if they took close to 18 credit hours. Knowing credit hours changes the book cost. As credit hours increase, book cost increases. So these are not two random variables like choosing 2 weights of apples where there's a known mean of 9 ounces and a known standard deviation of 1.5 ounces, and there's a little variety in apple size in that pack. Okay. Discuss how combining random variables is different from transforming random variables. Okay, so realize that we did do 2 different types of things so far. We did transformations of one random variable, the shape remains the same, center gets multiplication and division, and addition and subtraction. Spread only gets multiplication and division, no addition and subtraction. But when we combine random variables, the shape can get all mixed up, okay? But we do consider that if we have sums of normal random variables or differences of normal random variables, that our sum and difference of the series of random variables will be normal. So it remains normal when 2 normal random variables are combined. We also said in combining random variables that the sum is just the sum of all the mean of the sums is the sum of all the means, and the standard deviation of the sum or difference is the sum of the variances square rooted. Okay. So, a couple more practice problems. We examined the probability distribution of the random variable x equals the amount of life insurance a life insurance company earns on a randomly chosen 5-year term policy. The calculations reveal that mu x is 303 and sigma x is 9,700. If 4 21-year-old males are insured, the insurer's average income is, where X1 is the income for insuring one man and X2 is man 2, assuming that the amount of income earned on individual policies is independent from the mean, find the mean and standard deviation of V. Okay, so V is going to be mu V is all 4 men added up, as defined here, for 21-year-old men insured, and that 4 21-year-old men insured divided by 4 is 303.35. But the standard deviation is their variances squared, all added up, and then square rooted, and then divided by 4. So we're going to do that right there, and we get 4,853. Okay. All right. So do the combination of random variables first, then do the linear transformation. The design of an electric circuit for a toaster calls for a 100 ohm resistor and a 250 ohm resistor connected in a series that their resistances add. The components used are not perfectly uniform, so that the actual resistances vary independently according to a normal distribution. The resistance of a 100 ohm resistor has a mean of 100 ohms and a standard deviation of 2.5, while the 250 ohm resistor has a 250 ohm mean and a standard deviation of 2.8. What is the distribution of the total resistance of the 2 components in series for a randomly selected toaster? Let T equal the total resistance, very important because they didn't define that. The distribution of the total resistance is normal with a mean of mu T and a standard deviation of T. Okay? Find the probability that the total resistance for a randomly selected toaster lies between 345 and 355. So we're curious if the probability that T lies between 345 and 355. That's the probability that Z lies between the Z-score for 345 and 355. And that's between negative 1.33 and positive 1.33. And when I lay that all out, I get 0.816. The diameter C of a randomly selected large drink cup at a fast food restaurant follows a normal distribution with a mean of 3.96 inches and a standard deviation of 0.01 inches. The diameter L of a randomly selected large lid at a restaurant follows a normal distribution of 3.98 inches with a standard deviation of 0.02 inches. For a lid to fit a cup, the value L has to be bigger than the value of C. The lid has to be bigger than the cup, so it can fit on the cup, by not more than 0.06 inches. What is the probability that a randomly selected lid will fit on a randomly selected drink cup? Let D equal lid minus cup, where D is the difference in the 2 independent random normal variables, so D has a normal distribution with mu D equals this and standard deviation equals this. Find the probability that the D, the difference, is between 0 and 0.06. So we can't have the lid be the exact same size as the cup, or else it won't go on. We also can't have it be smaller than the cup, or else it won't work the way it's intended. It has to be bigger than the cup by as much as 0.06 inches bigger, or up to equal to the cup, but not, I did say including. Okay, so the probability of 0 to 0.06 for the difference is the same thing as the z-score for 0 and 0.06, and that gives us this interval of z-scores, and that gives us that probability.